Welcome to the statistics video, our first statistics video. The word is quite a tongue twister, so just bear with me as we go. So we're going to be looking at data and interpretation and representation of data. Let's start with what we see in front of us right now. In many situations, we deal with a lot of data. Take, for example, our growing world population, which reached 8 billion people in November 2022. We also talked about this in the economics video, the first one. Predictions were made some months prior to this development, and you may be wondering how the predictions were quite precise and accurate. It's not magic, it's mathematics. A lot of data on the world population was collected, mainly through census, and it was organized and analyzed by statisticians and other relevant professionals. These statisticians were the ones who interpreted the data, comparing it with the data and trends or patterns from previous decades, and found out that there was a high chance of or a high probability that the world population would reach 8 billion in November 2022. If you check the latest stats, which is short for statistics, it is expected that the world population will reach 10 billion in 2050. Basically, this branch of mathematics is responsible for allowing us to predict outcomes and be better prepared for the present and the future, particularly the future. After watching this entire video, you should be able to collect, represent, and interpret data in some of your journal activities, basically daily activities, maybe when you're at school, trying to find out how your results are looking, and maybe want to see the trends in your results over the years, or the marks that you have been getting in certain subjects over the years, as we're going to see in one of the examples that we're going to look at. It looks at those marks in school and all those dynamics, but the basic idea is you should be able to analyze your own data using the skills that you're going to get from this video and the knowledge that you're going to get from this video. So let's get on with it. Okay, so some key terms before we start so that we avoid confusion. Raw data is the data that was sampled or recorded without prior order. So if I want to take a list of things or collect a list of things, you just collect the stuff and then you record and make the list. So you don't need to put it in any order. It's more of you just taking the data. Maybe you're conducting a survey. How many people have cars in your area? Just take a survey. You just go randomly and ask people. And then afterwards, that's when you start grouping the data and analyzing and representing the data, as we shall see later on. And then the mean is the average of the data or events or the occurrences given by the equation mu, that's a Greek letter, equal to sigma, the capital letter sigma in Greek, multiplied by x, which is the occurrence or the event, over the total number of events or occurrences. So we find that it's the sum of x over n. We'll get to look at it later. Then the mode is the most occurring value or the number of events. So if I were to say how many people have birthdays in what's the month, let's say February, our current month. How many people have birthdays there? If we have a lot of people in a select group of people with birthdays in February, then that becomes the mode, that number of people with those birthdays in February. Then the median is the value that lies in the middle of the data. So it's right in the middle. What's that value in the middle? And then we have the tabulation or creating a table with organized data. So like I said, you collect the raw data, maybe with a survey or census or whatever, and then you tabulate. You put it in a table, organize everything, put columns and heads, and then the rows also might have headings, and then yeah, you just analyze the data as you go. Then frequency refers to the number of occurrences. You're going to understand that later on when we now look at grouped data. Okay, so our data is grouped into two. We have discrete data and then we have continuous data. So discrete data refers to the information that can only take exact or fixed values, like the head count or number of phones, counting the number of phones that you have, counting the stationery that you have, as fixed values. They can be in decimals as well, but they have to be fixed. They have to be independent, each occurrence. And then more points to note, discrete data can only accommodate what we see, fixed or exact values. And then raw data is the data that was sampled or recorded without any order. We looked at that before in the key terms. And then discrete data can be made up of decimal numbers as well, apart from the whole numbers, as aforementioned. Okay, so let's look at this example. of discrete data. One winter day, the security guard at a new shopping complex, it's a small shopping complex, you might be surprised with the values that you're going to see, but it's a small shopping complex. Let's put that in our minds, hypothetical. Wondered if people were ever going to show up at the shopping complex. So he decided to count the number of cars which arrived at the complex after every half an hour during his 7 working hours. So basically, after every half an hour, he would start counting again. The results were as follows. So those are the results we're now saying how many times did he collect the data. It was 14 times, because we're saying how many half hours are in an hour. It means there are 2 half hours in an hour. So if we say 2 by 7, we get 14. So we're saying there are 14 half hours. So there are 14 times in which he was collecting his data, or he was counting the cars that arrived. So the first question would be, state the type of data using the information provided. So the information provided is what's in that box, in that rectangle. And then the second question is, organize and tabulate the sampled data showing the frequency distribution. We're going to look at that. Then represent the data from the table in a vertical line graph, or rather end a histogram. We'll look at both ways of representing the data. So let's get on with it. So the answer to the first question is discrete raw data. It's raw because as you can see in the rectangle, the number of occurrences or the number of cars are just random in there. And then it's discrete because he was counting fixed value. So he could count, this is 1 car, this is the second car, this is the third car. There was no like a range of conjoined cars or whatever. No, there's independent cars coming at different times or in the same time. And then we have the number of cars there in the first row, and then the frequency in the second row, as you can see with the requirement of the part B of the question. So as you can see with the first, we're trying to say, for if we had 1 car coming in 30 minutes, then it means that the frequency has to show us how many half hours did we have 1 car coming. Like we said, this security guard was actually concerned that maybe people might not come because it's very cold, it's a winter day. So we see with 1 car, there was no half an hour that had 1 car coming. But with the 2 cars, we won't have 1 30-minute period. Then with 3 cars, 1 30-minute period. You can see that in that rectangle. So at the end of the day, if you add up all the frequencies, they should give you 14, because the frequency represents the number of 30-minute periods that are in that in the 7-hour working time for that security guard. So the security guard works for 7 hours, but after every 30 minutes, he was counting the number of cars that arrived. So I want to see how many 30-minute period did we get 2 cars? How many 30-minute period did we get 4 cars? How many 30-minute period did we get 10 cars? How many 30-minute period did we get a single car? Or how many 30-minute period did we not even get 1 car? That's basically what the frequency is trying to entail or show. So we then see that being portrayed there, and 6 cars came in almost 4 30-minute periods. So that's the mode. So if we are to present it in a line graph, that's how it will look like. So we have to put the scales for, you have to decide the scale by yourself. So you decide, okay, what fits on that line. It will be from 0 to 10 in the horizontal, and 0 to 4 on the vertical for the frequency and the number of cars. Make sure you label with the titles that you gave for each row in that table. That's the one you use for the graph, so that it makes sense. And then we move on to the histogram, which is basically the same idea. So you're going to see that the only difference is with histograms we have sort of rectangles. Those rectangles, maybe we call them bars, but let's just call them rectangles, and you put them in different colors so that you can distinguish that they are for different values. And as you can see, the values for the number of cars, they are directly in the middle of those rectangles. So it shows you that that's where the peak number is, the average number there. And then you are going to see that they are joined together. That's why we call it the histogram. For bar graphs, it's a bit different. They have equal spacing between each and between the rectangles. So you have to take note of the difference between a histogram and a bar graph. We're going to see the bar graph later on, but this is what we call the histogram. So this is how you represent the information. You take the values from the table, and then you put your scales, you show the ranges of your scale and all that, and then you plot the graphs according to what's in your table, and then you'll be good to see which one has the highest and which one has the lowest values as it is graphically represented. And it's better to also put it that way for the layman to understand. You get what I'm saying when you look at the graphs, unless if you're very interested in values and digits and all that, yeah, then the table is good for you, but the graph makes it easier for almost everyone to understand. Now we move on to continuous data. So contrary to the discrete data, continuous data is the quantitative data that can take or accommodate any value, not limited to exact values. So it can be approximate, it can be specially approximated values. You're going to see that that's when we introduce ranges and what we call upper bounds and lower bounds, and then we have a range of values. You're going to see that later on, and that's when the values are not exact or fixed. And then we have other points. We say continuous data is not limited to exact values or particular events, as aforementioned. This information can show trends in data over a period of time. That's basically continuous, because with time you're going to see that things change. They're not fixed. Events won't be fixed. They will be changing as time moves on. So it's good to call that continuous data. And other examples are length. You can take ranges of length, or maybe height of people. Many examples of people's height, or maybe shoe sizes. Many people have different shoe sizes. Yes, and all the like. Basically, there have to be some continuous or continuity of the values, or approximation of some sort, as with an example that we're going to look at very soon. Okay, so the example says the traffic police department, hypothetical one, identified a new high accident zone. So they sent some traffic officers to track the speed of each car that passes through the zone, and they had to do this in half an hour, and then send the data to the department officers for analysis. The following was the raw data in kilometers per hour for 20 cars. So it was just in one 30-minute session. Those are the speeds. Using the information provided, state the type of data. As you know, that is going to be continuous raw data, as you can see. And then on the second question, it says, what is the modal speed and the median? So we're going to look at that, and you draw the tally chart according to C, with the columns for speed, tally, and frequency. And then you present the data by drawing a histogram. So let's get on with that. Okay, so the first question, we already answered it. This data is called continuous raw data. Because we can see even the speeds, we are only seeing one value for each speed for each car. But the fact is, those cars were not moving at that speed exactly. They were moving in a range of speeds, but we had to take one value. So when they were taking with their radar or their speed tracker, whatever they were using just to track the speed, they just took one value, and that's the one they sent to the department's office. So those are the speeds that we saw. And then the B part says the modal speed is 125 kilometers per hour. So you see how many 125s are there, how many hundreds are there, how many 80s are there, if there are any 80 kilometers per hour. Since it's a high accident zone, we're expecting that there are more cars that are moving above 80 kilometers per hour or beyond 100. So moving at very fast speeds, basically. That's why we're suspecting that's why we have many accidents, because of those high speeds that we are seeing in that rectangle. So according to our data, 125 kilometers per hour occurs twice in that collection of data, and that means that becomes the mode, because all the other speeds are occurring once. It's the only one that's occurring more than once. And then the mean speed is approximately 149 kilometers per hour. Correct to three significant figures. The mean is found by adding all those speeds that you saw, and then you divide by the number of occurrences. So here we have our number of occurrences, which is 20. We have 20 different cars that we recorded their speeds, and then we divide that into the total number of speeds. if we add all the speeds together and then we divide by 20, we then get that 149 kilometers per hour. So with the tally, we just use that way of counting. With the tally, is just use the strokes and then you are good to go. It's an easy way of writing than using the Roman, rather not Roman numerals, the Arabic numerals. They might take you time to list everything, but if you just take those strokes, you might be able to do it fast. So the frequency now, you then do it after you're done taking off all those values, and then you write down the actual figures in Arabic numerals, which are 2, 4, 6, 5, 2, as you can see, and then you draw your histogram with the speeds on the horizontal axis and the frequency on the vertical axis. I think we already know how to do that histogram. As I said, you use the values that are in the table, and then you put your scale. You decide, is it from 0 to 10 or 0 to 5 or 0 to 100 or 0 to 20, or you can even start in the middle. You can start with 5, not even from 0. Start with 5, 10, 15, 20. You can decide the scale. You can decide how you want it to look, and then you just plot your histogram accordingly, according to your scale, and then you analyze the appearance of the histogram and what it's showing you. You can even comment on the skewness. Like with this one, it is positively skewed, so it's towards the negative side of the number line, but it will be positively skewed. The skewness is different from the direction of the number line, so that's something that you might be required to comment on, the skewness. And with the previous example that you looked at, the previous histogram in the line graph, in the discrete example, we see that one, it's negatively skewed. It's more to the right, more to the positive side of the number line, so it's negatively skewed. Then the other thing that I want you to take note of is the speed column. We put the units, it's kilometers per hour. Then also we put the ranges. We don't put each and every number or each and every speed, because look at the speeds, they are big values and they are a lot. 20 is a lot. You don't want to write all 20 speeds in that column, so just put ranges. When you have a lot of data to group, you have to put it in ranges so that you don't deal with a lot of data, because what you want is to then represent that data on a graph or on a pie chart or on a box and whisker plot or whatever. You want to then represent that data, and you don't want a lot of numbers to deal with. You just want ranges so that you can see the shape of the graph. You're not concerned about the exact values or the continuous values or how the raw numbers are, but you're concerned about the trend in those values, and you are concerned about how they are distributed. We're going to look at distribution of data and of probability and all that later on in our next episodes, our future episodes. Probably it will be one of our last episodes, I am assuming, on distributions. We have normal, geometric, binomial, Poisson, many types of distributions that we can use, and approximations of the distribution. We're going to look at all of that, but you don't want to look at all those distributions with each and every data applied on those distributions. You just want to look at how they are looking, how it is looking like, how the data is looking like, not focusing on each and every value, because that takes a long time and it's very unnecessary. If you summarize it, you're basically doing a lot of favor, and you won't have to deal with a bigger scale on your graphs, and you deal with a smaller scale and still come up with the graph and with the conclusion that you want to come up with concerning your interpretation of the data. So let's now move on to the stem and leaf. Okay, as aforementioned, we are going to look at stem and leaf diagram with students and their marks in different subjects. So a class of 16 students set for a literature exam first, followed by a business exam on the same day. Each exam was out of 50 marks. Their marks were as follows, as you can see in those, the literature marks and the business marks. Using the information provided, you're supposed to plot a stem plot and a box and whisker plot to represent the marks, and then you have to see which subject had the high mean, and then you have to calculate the pass rates for each of the two subjects. So for both of them, you have to calculate their respective pass rates. Okay, so this is how we plot the stem and leaf. The stem and leaf is what you see in white on top there. From that key, that rectangle with the key going upwards, that's the stem and leaf. And then those funny box and whisker things there, that's the box and whisker plot with the scale at the bottom there. So let's start with the stem and leaf diagram. What we do is we have to define how we are going to be putting the stem and leaf. So since we have two subjects, we don't have to put them separately as individuals, so we can put them together, but the tens and the units have to be separated. So what you see in between those two white lines, the 0, 1, 2, 3, 4, those are the tens, and then our units are what we see on the business side and on the literature side, and we start counting from the white line going outwards. So this is why you see with the key, it says where there is 9, 0 and 5. The 0 is in the middle, that's the 10. And then the units are 5 and 9. So which means we have 5 marks for business, for literature, and 5 marks for business. And then the next one is 3, 1 and 2. So which means there's 31 marks for business and 32 marks for the literature, respectively. So this is how we write them. And then you just compare with what you see in your rectangle, which is the values or the marks. You just see the list of the marks, and then you put and you arrange them accordingly. So like you see with the ones that start with 1 as their 10, you see we have 13, 15, 17, 19 and 19 for business, and 10, 10, 5, 15, 18, 18 and 19 for literature. That's how you just do it. So don't forget that after putting the stem and leaf, you have to show the key. Basically it explains how people should read your stem and leaf diagram. And then we move on to the box and whisker. So what you're seeing is the box, that's what you see in the middle, and then those lines that extend to the far right and far left, those are the whiskers. I think it's self-explanatory, you can just see that. So the ends of the whiskers show the highest value and the lowest value being at the left and the highest value being at the right, is shown with the scale at the bottom there. You're doing it relative to the scale at the bottom. So again, you're the one who decides the scale, then you put it. And then in the box, the left side of the box is the Q1, which we call the lower quartile, and then the right side of the box is what we call the Q2, or rather Q3. The Q2 is the median, then Q3 is the upper quartile, which is basically 75% of the values that you see, of the positions of the values or the occurrences of the values on your stem and leaf. Okay, so if you see on the literature side, we start counting where there is the 8. So it's for the lower quartile, which is we use the equation or the expression or the formula 1 over 4 of n plus 1, which in this case would be 1 over 4 of we have 16 members, so we say 17. So it's 1 over 4 of 17, then we get our value. But in this case we just use what we have done here, which is 0, 9. Instead of calculating, we just count. So we have 4 that we are considering here, which will give us 10 as our lower quartile. Therefore we put Q1 as our lower quartile. And then we calculate again, our median is between 19 and 20, so it's around 19.5. And then we put between 19 and 20 there. And then our upper quartile, which is Q3, is at around 29. And then we put our upper quartile there, 29. So that's how we do it, and then we complete the box. So we just put lines, vertical lines that show those positions, and then we complete the box of the lower quartile, upper quartile, and the median according to our scale. And then we extend whiskers to the ends to show the highest value of the data that's there, and the lowest value in the data that's there. And then we put other vertical lines at the ends of the whiskers just to show where the values are. And then there you are, you have plotted your box and whisker. If you want, you can then show this Q1, Q2, Q3 as we have done. The same applies with the business one. You don't have to create another line with another scale for the business. You can just use the same one, because we're saying the values can fit also in that line. So all we do is just to reposition the box and whisker plots, and then we can see how it is arranged, same way of arranging. But I want you to notice that the median for the literature one shifts compared to the business one. It shifts towards the right, which means it's negatively skewed, and then the business one shifts to the left, which is positively skewed according to the median. But if you look at the boxes, the box of the business shifts to the left, which means it's positively skewed. Also the literature box shifts to the left, which means the box is also positively skewed. And then if you see on the quartiles for the business, we also show that Q1 is 25%, which means the quarter. Q2 is the median, which means it's halfway. As we see, it's in the middle. And then Q3 is 75%, which is the upper quarter, which means it's 3/4. That's basically 75%. Basically, that's how we do the box and whisker, and that's how we do the stem and leaf. So I hope you understood this one in particular. You thank me later. Let's move on. So I think you remember the equation that we saw in our key terms. Mu is equal to the sum of x over n, which is the total number of occurrences. If we look at our b part, that's what we're going to be applying. So our sum of x in this case would be 352 for literature and 423 for business. And if we see they're both over 16, which means there are 16 numbers that we're dealing with for each case, and then that would be equal to 22 as the mean for literature and 26.4 as the mean for business, which implies that business is the higher mean, because 26.4 is greater than 22.0. So that's the greatest mark of the two, or the greater mark of the two means. That's how you basically answer the question. Just comparing how people were passing. So on an average, we're saying business was passed by most students compared to literature, and that will be shown again in the next part, which is the calculation of the pass rate. Okay, so for the pass rate, we can see that we collect the numbers of the total number of people passed for each subject. So as we see, the question says that from 20 marks and above, you would have passed the subject. So we look at those who had 20 and above. For the literature exam, we see we have 8. And then for the business, we have 10. And you can see how we got those numbers. We got them from the raw data that's disorganized. And then therefore, the pass rate for the literature exam will be 8 over 16, because there are 16 in total, 16 students that took the exam. Multiply by 100, and then we get 50%. So which means half of the class passed and half of the class failed the subject. And then for the business exam, it's 10 out of 16 by 100, which gives us 62.5%, which means 62.5%, correct to one decimal place, passed the exam, and then the rest failed. That's basically what it means. So which means 62.5 being greater than 50, we then say the business exam was passed more than the literature exam. And you then see in most cases the principal will use these values, these statistics, to interrogate those who are responsible for this poor and appalling performance in the exam, and find out why these students are failing. And then certain measures will be taken to avoid that in future examinations, because no one wants to fail. So we need the statistics to follow up on the performance of students. That's one way in which statistics is applied, and where the stem and leaf and box and whisker, whatever's diagrams are used. They are also important. I'm not saying they're less important, they're very important. So let's move on. Okay, so now we're looking at pie charts and bar graphs, and as you can see on the bottom right corner, we have an example from one of our videos where we used bar graphs, which was the video on Mercury. I think that should be Mercury. Yes, just the Mercury planets in our universe, Mercury video. We used these bar graph that you see on the bottom right. So we apply the statistic principles in our videos. So don't worry, you're not gaining information from nowhere. You get to understand where it is derived from and how we use it in our videos, so that we get to understand this phenomenon and all these things that we find in our lives, in this universe, and generally in our world. So we get to understand trends, patterns, and also get to find the probability of certain events happening in future. Okay, so let's get on with this example on pie charts and bar graphs. Okay, so in this case we don't have raw data, as you can see. So some subscribers to the Shumbafoot creative space, some of you guys, hypothetically, wanted to know the type of content which appears the most on the YouTube channel. So they categorize the videos on the channel and recorded the data. You can also do the same if you are interested and maybe show how you have done it. The following is the tabulated information. As you can see, it's already organized, so you don't call it raw data, it's already grouped and organized. So using the information provided, draw the pie charts clearly and also label the represented data, and then draw clearly the labeled bar graph as well, and then you have to say which category has the most videos, basically the mode of the list of categories that you have there. So let's get on with that question, those questions. Okay, so you might be asked to just approximately show the pie chart and not really show exactly how it looks like with the correct angles, but first of all you have to calculate so that you can see how you're going to estimate. But in some cases you may be asked to draw an accurate pie chart where you can actually show the angles and how they look like. As you can see there, we have to show how it looks like. It will be good to use a protractor. We have a tool called the protractor, very special tool, very important, very unique, and very helpful in this case. So what you need to know first is the total number of videos. If you add all of them, the total number, which is n, is equal to 50. And so we then calculate the angles. Basically you say the number of videos for the category divided by the total number of videos that were listed, or rather that were considered by the group of subscribers. Then you multiply that by 360. Why 360? Because 360 degrees as the angle for a complete revolution, a complete circle. It's 360 degrees. So we want to create the pie chart using a complete revolution, so we have to put it to 360 degrees. But if we're just dealing with maybe 180 degrees, it means we multiply by 180 degrees, showing that half moon. Yes, that's another way of doing it, but usually pie charts we deal with 360 degrees. So let's see how we calculate it there. So basically 50 videos corresponds to the 360 degrees, and then we do those calculations, we multiply with 360 degrees the number of videos over the total number of videos, and then we get the angle. And then we come to the pie chart, and then we use a protractor. With the center, we have to define the center where it is, and then you should use the protractor accordingly. And then you also use the diameter to help you with the protractor, the radius, depending on how you want to use the protractor. But at the end of the day, you have to show those angles. As you can see, at the end of the day, that's how the pie chart is going to look like. So you just plot your marks, and then you extend lines to their respective marks, and then you can come up with that circular pie chart with those sectors. We call them sectors. What you are seeing, those triangle like shapes there, they're not triangles, don't say they're triangles, but in this case, let's just, for those who don't know what sectors are, it's basically those parts when you cut a cake. Yeah, that piece of cake that you cut is what we call a sector, from the center to the arc, to the edge of the circumference of that circle. And then another radius again in that case, and then we get the sector, or any chord. Okay, no, not a chord, but like a line that extends from the center to the curve, or to the circumference, which is the radius. And then you have your sector. And yeah, you can decide to label, as you can see, or you can even add the percentage. So for example, without changing what you can see, the only thing you change is the 360. On those calculations, you put 100, like we did with the pass rates. Yes. So let's take, for example, 5 over 50 by 100. That's 15 to 100. That's 2 times 5. That's 10. So it's 10%. So that's 10% for biology. So where there's biology, you write biology, and then below it you write 10%. So you can label it that way. There are many different ways of labeling. You can even color with different shades in the sectors, and then you put a key which shows that this sector with this design is this represents culture, and then this other sector represents summits. Depending on how you want to design it, it's up to you. At the end of the pie chart, you have to show that each sector has been represented, each and every category has been represented. Then let's skip to question C, which says what's the mode, which category is the modal number of videos, and that happens to be culture, the culture category, which is 18 videos. That's the highest number of videos compared to the other videos in the other categories. So now let's move on to the bar graph. We put on our dependent axis or our vertical axis the number of videos, and the category in our horizontal axis, because with bars we're just labeling them. So the horizontal axis is the one where we label, and then the vertical axis shows the height. The height then shows you to what extent is the number of videos a lot or a few, or you can then compare with the height. And then we can see that the bar for the culture is greater than the rest. That's why we say it is the model. And then you decide the scale for the number of videos. So since we have the highest number being 18, which means our scale can reach to 20. 20 is enough. Then we just use 5, 10, 15, 20 in terms of fives, and then we get our scale. And that's how we do the bar graph. Then one thing I also want us to notice is the difference between the bar graph and the histogram. The histogram, the bars or the rectangles were close together, they were attached, but these ones are detached. So we see that they are detached with or rather equal distances between the bars, and also these ones, their class width is the same, as you can see. But with the histogram, most of the time the histograms have different class widths, as you're going to see in the next example with the cumulative frequencies. Okay, now move on to cumulative frequency curves. The example we have is a certain librarian wanted to find out which age groups visit library more often. She was planning on buying relevant books for them to replace the old books on the shelves. Or rather order, not really buy, but order more books. The following histogram shows the data she got from her records. The first question says, so what you're seeing from the histogram there, that's the white histogram, that's basically the data. So you just analyze, it's already represented. So what you now need to do is to use what was represented to also represent again. There are reasons why you may need to put it as a cumulative frequency curve. You maybe want to find the quartiles, like we're going to do later on. So with the first question, compute the total number of people who visit the library regularly, and then what is the mean age. Then draw a table of group data from the histogram. So using the histogram to draw the table with all those columns stated, and probably more. Using the table in C, draw a cumulative frequency curve to represent the data, and use the curve to determine the quartiles and the median, or to find the quartiles and the median. So basically you're using that histogram to do all that. And then the axis, we have the age in years on the horizontal axis, and then the frequency density. Frequency density is the quotient of frequency over class width. Basically frequency divided by class width is equal to frequency density. What else may you need to know? Okay, then we have the class width. We can see how broad the rectangles are compared to the bar graphs. Yes, they are now broad, and some are not broad, they are narrow and all that. The differences of those ranges of ages which are covered by each and every let's call them rectangles. Yes, each and every rectangle represents the class width. How broad they are is the class width. Okay, so the total number of people who visit, remember frequency represents the amount of occurrences, so it's basically the number of people. If we add the frequencies, we then get 268. That's the total number of people. So we have 40 people in the first with the first range of ages from 0 to 10, and then from 10 to 30 we have 100 people. From 30 to 40 years we have 32 people. From 40 to 70 we have 66 people. That's basically how we do it, and on and on. And then we then draw a table with the age in years. The median is x. The median is basically the difference or rather the sum of the upper bound and lower bound. The lower bound is, in the first case, 0, and then the upper bound is 10. The next case, it's the lower bound is 10 and the upper bound is 30. In the next case, the lower bound is 30, the upper bound is 40. So the sum of the two, so if you say 0 plus 10, you get 10 divided by 2, it becomes 5. That's your median. 10 plus 30, that's 40, divided by 2, that's 20. So it's basically the number in the middle between the upper bound and the lower bound. So the expression will be upper bound plus the lower bound divided by 2. Then get the median. And then we move on to the frequency. The frequency, like I said, that's the number of people, so we already calculated that. Then the frequency density is the frequency over the class width. The class width, like I said, if you look on the histogram, how thick or how broad the individual rectangles or individual bars are determines the class width. So from 0 to 10, that's the class width. So it's the difference between the upper bound and the lower bound. So 30 minus 10 will give you 20, as you can see. Then 70 minus 40 will give you 30. 100 minus 70 will give you 30. So the class width is the difference between the upper bound and the lower bound, which is basically the thickness of the rectangle or the histogram bars. So to get the frequency, we basically say frequency density multiplied by the class width. It's the product of the frequency density and the class width. So we see the first case, 4 times 10 will give you 40, 5 times 20 will give you 100, 3.2 times 10 will give you 32, 2.2 times 30 will give you 66, as you go on. 1 times 30 is 30. And then the cumulative frequency is how much more of the frequency increases as we move from 0 years to 100 years. So at 0 to 10 we get 40, but from 0 to 30 we then say 40 plus 100, we get 140. Then from 0 to 40 years we say 140 plus 32 will give you 172. From 0 to 70 years we have 172 plus 66 will give you 238. From 0 to 100 years we have 238 plus 30 will give you 268, which is basically the amount of people that visit. The n that we found in A will be the last figure that you should get. If you don't get that figure, then there's something wrong. You should the cumulative frequency should end with the total number of people or the total number of occurrences, or the total number of frequencies, you see. So when you add all the frequencies, it should add up to that last number, which is 238 in this, or 268 in this example. So that's how our table looks like. Maybe if you want to be experimental, you may add more things, but these are the crucial figures that you need for now. And this might take you a lot of time to create, but it's worth creating so that you can plot your cumulative frequency curve